All right, here we go. So we're going to do galvanic cells. So first of all, it's important to note that galvanic cells convert chemical energy to electric energy. Now, sorry, I'm not excited. To electrical energy. And so what electricity is, it's actually electrons moving from an anode to a cathode. Now, if you had been in honors, if you were in honors, you might remember Thomson's experiment where he had a glass tube and he ran an electrical current from the cathode end to the anode end, the anode end to the cathode end, and he watched the gas inside light up. And by doing this, he was able to actually discover that there were electrons in gases. This is how John Thomson discovered electrons. So that is where you would have first heard anode and cathode, but we're going to talk a lot more about it. So that's A to C, and I'm going to C. I'm going to give you like a lot of tips here. So A to C, alphabetical. We ran alphabetical. All right. So in a battery, we have two beakers, and this is what your picture is going to look like on the test. And in those beakers, we have electrodes. So here are my electrodes, and here are my beakers. Okay, and then these electrodes are connected by a wire which goes through a load on fire. And that load on fire for us is like a switch, but it could be a light bulb, it could be a meter. It's called a load on fire, a load, basically, all right? And then connecting that is this, what is called a salt bridge. And it's like a curved bridge which is usually filled with gel. So this, we'll do this, is the salt bridge. And we'll talk a little bit about the salt bridge. Okay? Now, we need to give these anodes, these electrodes, some metal identification. So the metal identification that we're going to give them is we're going to give the left one, we're going to make it zinc. And the right one, we're going to make it copper. And we're going to put in the solution, we're going to make this solution, which, all right, we're going to make the solution copper sulfate, zinc sulfate over here. And so over here, we're going to make a copper sulfate. Okay, now, copper likes to gain electrons, which we will talk about how we know this later. Okay, but copper likes to gain electrons. And so our reaction here is going to be Cu plus 2 electrons yields copper. And so this is going to be aqueous, and this is going to be solid. Zinc likes to get rid of electrons, so we're going to, over here, have zinc solid, And so it's going to give away electrons. So we're going to end up with zinc plus 2, which is going to be aqueous, plus 2 electrons. And these are called half reactions. And you can see why they're called half reactions, because one cannot go without the other. Because as one loses electrons, the other gains electrons. As one electrode loses electrons, the other electrode gains electrons. We're not done with the picture yet, okay? All right, so this is the anode. And remember, we start at the anode. So this is the anode. We start at the anode. Electrons are lost here. Lose electrons, oxide. Remember Leo, you guys know Leo goes grr? Okay. So this is oxidation. The electrons travel through the wire to the load on fire. See how this is happening? Oh, what a great song. We love it. So they're going this direction. The electrons are. And through the load on fire. They enter the cathode. And reduce the cation. So this is gaining electrons, so they are reduced. See? Right? Gaining electrons. All right? And we're going to hold off on the anions going through the Saltridge, right? So we're going to hold off on that. So it is this transfer of electrons that causes the electricity to run. See that? So the zinc is the negative electrode on the battery. Why is it negative? Because it's got these electrons going, and the electrons are attracted to the positive electrode, because electrons are negative. So they're attracted to the positive electrode. Now, what's happening over here, and we're going to summarize all of this, but I'm like telling you, right? What's happening over here is the copper 2+ in solution. Because remember how, like, we put this into water and it separates into ions? The copper 2+ is attracted to the electrons that are coming into this electrode. So what happens is it goes like this, and it gains that 2 electrons, and the copper 2+ is like deposited onto that electrode. So that electrode ultimately gains mass. I'm going to repeat that, what I just said. So the copper sulfate goes into solution and splits up because it's aqueous. So it goes into solution, and you have copper 2+ and SO4- floating around in this solution, right? So we're just going to put this over here really small. We don't really care about it right this minute, right? The copper 2+ is attracted to the electrons that are coming into this cathode. And so it goes over here and it picks up those 2 electrons. Here it is, picking up those 2 electrons. And when it does, it becomes copper and it attaches itself to this electrode. So what happens to this electrode? It gets bigger, because more copper is being deposited. This, by the way, is what electroplating is. This is a form of electroplating. So this copper electrode is getting larger because copper is being deposited on it. Every 2 electrons that comes over deposits one atom of copper onto this electrode. Are there questions so far? I haven't even told you the whole story. This is just like the very fundamentals, okay? Meanwhile, over here, the zinc atoms in the electrode, right? The zinc atoms in the electrode are losing electrons. And so as they are losing electrons, they are going into solution as zinc plus 2. So what's happening to the mass of the zinc electrode? It's decreasing, right? Okay, there's a whole calculation that goes along with that, right? In your packet, like there's grams per coulomb and blah, 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 a whole calculation. Like how many grams of the electrode will be gone after this much time? And remember I said there are problems for 1 through 5s? That's a 5 problem. What's the mass of the electrode that will be gone? Okay? All right. So, the copper, so 2 beakers, so now a little bit, so this is the basic, this is what we're doing. So this is losing mass. I'm watching the time because we're running out of time. In fact, we're kind of out of time. And this one is gaining mass, 809. We're just going to put this in and we're done. 809. We are done. Class is over. Now, what I would